Hi, this video is going to be for our notes on observations, of what an observation is, how we do a good observation, and what some of those terms are as we use observations here in science. So, in biology and in all sciences, we use observations, and observations are basically a term we use for any way that we are collecting information. And we do this using our five senses, and we should know these. It's our sight, smell, taste, hearing, touch, and touch. And if you can't have it within the five senses, then it is not an observation, then you're getting into something a little bit different. So as long as we can observe something, we refer to it as an observation. Now, often people will confuse the term observation and inference. So inferences take observations to another step. So with an inference, inferences actually allow for prior knowledge. So an inference is where we take an observation and we add in some prior knowledge and experience to allow for an interpretation. So we might observe somebody in a heavy parka, and we would say, oh, this person has on a heavy parka. An inference would be that it's cold outside. We cannot include that it's cold outside unless we actually went outside and we felt that in science. You actually have to have the data. The inferences, you have to really be clear if they're inferences or if that was actually observed. The other piece that often gets mixed in and that people often confuse are predictions. So predictions also use our prior knowledge like inferences, but this time it is trying to decide what is most likely going to happen. So if we know that it's very, very cold outside, we might predict people are going to wear heavy coats. This should make sense to everybody as far as the differences between these three terms. Alright, so we use observations all the time. There is casual observations that we use in everyday life, and then there's scientific observations, and they're a little bit different. Alright, so in a casual observations, they're random. It's whatever you happen to notice. In a scientific observation, you really want it to not be random. You want it to be quantified. You want to be really looking for things. Also in casual observations, it can include inferences. We often will say, oh, well, what did you think about this? Or what did you see? Tell me about it. And we include both our observations and our inferences in our language as we go through and describe what happened. Casual observations are unsystematic. When we describe somebody, everyone doesn't immediately start the description of how somebody looks with how tall they are or what their hair is like. They might start out with a piece of attire that they always wear. They might start out with a skin tone or a tone of voice, or how you might know them, of where you see them. We don't record casual observations formally. We usually don't have them written down. We aren't taking notes on them. We don't have data tables of casual observations in our everyday life. We also usually don't have measurements or scales. If you're talking about how tall somebody is, usually it's a comparative value. We don't usually go, oh, well, they are exactly 6 foot 3 inches and 2 centimeters. We don't usually do that. So it usually is missing either measurements or scales in those observations, and we use more of comparative of, the person who is taller than this other person. Alright, so this is different from scientific observations. Scientific observations, we want to quantify whenever possible. So if there is a measurement that we can take, we take it. So you want to see how tall are they, how big are they, what's the weight, what's the width. Every single thing that you can take a measurement on, we try to do in science when we're taking observations that are detailed. Scientific observations are considered factual, no inferences. So inferences, because everyone's prior knowledge is a little bit different, several people could see the exact same situation and have several different inferences. So it no longer becomes a factual statement of what's happening. So in science we try and exterminate all inferences of what we think is going on. If we can't measure it, it doesn't count. Alright, we record them. we always record our scientific observations. We put them in data tables. We want to have a hard record of them, because then if someone goes to repeat our experiment, we want to have our hard data so they can compare their hard data to our hard data. It's systematic. We don't just measure how tall the plant got whenever we think about it. We will go and we will measure it every day or every week. We are very systematic. We want to make sure it's a repeatable experiment, that we know how far apart our data points are. And it's detailed. We take way more data than we probably need, just in case there's something else affecting what's going on that we weren't aware of. Okay, so these are the two main types of observation. So there are a couple of key words dealing with this that I want to make sure that we understand. So we have our observations, our inferences, and our predictions. So in science, we refer to observation that's collected. So we do our data that's our observations, and we're collecting these observations, and we refer to them all as data. Our data is what we refer to our observations as in science. When we make inferences about that data, of what we think it means, these are our conclusions. We usually see this either in the analysis or conclusions part in our labs, but they are considered a conclusion from the data of what we think that data means based on our prior experience. And finally, when we make our predictions about what we think is going to happen, those we refer to as our hypotheses. And our hypotheses are predictions, and we go through and we test them and we see if we're right. Now, when we do observations, there's two main types. We have quantitative, and if you look at the term quantitative, which is right here, you'll notice that there is a term here that looks kind of like the beginning of the term quantity. And that is important because quantitative uses numbers. It's trying to figure out what quantity does this have. We have measurements. We often use tools to collect quantitative measurements. Okay, these are what is our volume, the length, the weight, how many of things. It stands alone. It doesn't require any comparative values. You can very much look and say, is this a 6-inch item or is it a 10-inch item? And that stands alone. It doesn't need to be compared to anything else. Same way as you can look at something and say, well, does it have 6 legs or 8 legs? You don't need multiple organisms there to look at them and say, oh, that's got 6 and this has 8. So the other term that we use when we make observations are for the ones that you can't quantify. You can't pin a number on that observation. There's many, many things that we have qualitative or qualities. So if we go here and we look, this one is very similar to the word qualities. And qualitative observations are looking at qualities. This is when we talk about the color. If something is brown, red, green, purple, if it's shiny or dull looking, if it's rough or smooth, none of these very easily go and translate into a number system. Therefore, we refer to them as qualitative observations. There are no numbers. They're usually either in descriptions or drawings. We often collect this data using recording devices, so this is where you often will see either an illustration or a photograph to try and describe an organism based on qualitative descriptions. It's also comparing samples, so you'll also see in qualitative things, this one's big, organism A is bigger than organism B. That's qualitative. We can't, unless we have an actual measurement that says organism A is 10 inches tall and organism B is 8 inches tall, it's considered qualitative. We need those hard numbers to call it a quantity. Alright, hopefully this has clarified what our differences between our observations, our inferences, and our predictions are, and our difference between quantitative and qualitative. Thank you.